Hey everybody, Jeff here. Welcome back to the channel. Tonight we're talking about the official investigation into the Champlain Towers condo collapse and what the government is up to right now. What's the current status? What is all of the information they have? So we're going to dive into it right now. It appears that NIST is going to give us an update probably every 6 months. So the last one they gave us was in November. So I'll put a link in the video description below so you can go back and check out what we reported back then. And then in February of this year, they gave us this update of the NIST Champlain Towers South investigation. They added some new expert team members. So NIST has brought in an FIU professor here named Emel Ganapati, and she will serve as the social science team leader. But I'm glad that they are at least doing it. So what they're going to be doing is interviews of residents, first responders, family members, other people with knowledge in the building's condition, collapse events.
My name is Emel Ganapati. I'm an associate professor at the Department of Public Policy and Administration at Florida International University. I will be leading the social science team as part of the investigation. Social science research is going to support the technical investigation, what our engineers and forensic scientists are doing. Social science research is going to also help us understand the context, what happened, what time it happened, who was there, how were things changed from the plans, because we're trying to solve a puzzle here, right? A technical puzzle as to why the building collapsed. Different actors have different knowledge about this building, so they all bring something different to the table and help us understand different aspects of the problem.
In this video, we're going to review the status of the National Construction Safety Team investigation into the partial collapse of the Champlain Towers South condominium in Surfside, Florida. This meeting took place on June 8th and 9th of 2022. So this is typically what the NIST investigation Zoom calls look like. Each of the presenters gets up there and talks for a bit.
Focused on establishing the likely technical cause or causes of the building failure, recommending as necessary specific improvements to building standards, codes, and practice.
Now, typically what they show you on the screen is kind of fuzzy, but I have their original slides here. What she reiterated for us was back in July is when they started to do all the tagging and collecting the evidence, and then you remember they cleared off the site. In August, they started doing subsurface investigation and non-destructive testing. And then here is the 6 teams and the 6 projects that they announced. Slide back in November, actually. And they actually ended their Florida deployment in September. So all of their people, I guess, packed up and left. And here's that complex slide that they presented at their meeting in November, showing the interaction of all the different projects that they were working on to come up with the final root cause of the condo collapse. Now here's their cooperative timeline that they gave. So this was the first time that they were giving us any kind of dates of when they think stuff is going to happen, and joint protocol testing that they're doing with different people. And then here's what they showed in January, where it said they named the social science lead and the custody of evidence. NIST has since procured at least 2 inside warehouses. And remember that NIST has a statutory obligation under the National Construction Safety Team Act to investigate and to preserve the evidence related to the building failure. So that's why they have a lot of it in this building here. So this is 2 new pictures here that we hadn't seen before. So let's take a closer look. Here's one of at least 2 warehouse bays that they have. And you can see they've saved numerous columns there, and they've got them all on the floor and everything. And everything's bagged and tagged and everything. And don't forget, they also did all sorts of photographs, 3D digital imaging, and LiDAR and other laser pictures and stuff like that of everything before they were removed from the site. So they know exactly where every one of these pieces came from on the rubble pile. And that's very important to be able to maintain that, a good custody chain there. So right here is one of the early software models that they created of the Champlain Towers condominium. So I've sort of maintained all along that the planters were right here. I have only said it was this column here that probably fell first, the M11.1, because if you remember, the tourists were shooting across the street. Here's the ramp. You can barely see it through there, shooting down the ramp, and it was the column there that was missing from her video. Now, other evidence has come through from the Miami Herald in the last month or so, where they showed us pictures that were taken 2 weeks before the collapse that showed the planter over here severely cracking. And now some people are saying that the column column over here for space number 76 could be a point of interest to look into also. Okay, then in February, they had to do what they call phase 1 protocol warehouse air sampling, and they needed to make sure that there wasn't any asbestos in there because the EPA has all these rules and regulations, and so it came back with negative on the asbestos, which is what I would have expected anyway, because they quit using asbestos, I don't know when, maybe in the early 70s, and so certainly this building was completed in 81, so I wouldn't have expected any asbestos to be in it. And then what happened here, what you're looking at here is the setup that they had made for all of the plaintiffs of the lawsuit. So they had petitioned the court, the judge, Michael Hansman, in this case here, in the class action lawsuit for the Champlain Towers South plaintiffs, granted them access to be able to see this evidence under the custody, of course, of NIST. So this occurred during February and March. Okay, and then in March, they did warehouse scanning and data integration for 3D. They scanned everything that was in there in that warehouse. Here it is right here. So let me zoom into these for you. So what NIST did was they got these high-resolution 3D photos of looking down inside their warehouse. These are all the columns and the beams and slabs and whatever they were able to get there. And they've got them all laid out and tagged so that any member of the team can zoom in on these pictures when they're not in the facility itself. So they could zoom in and get closer looks at all of these columns. So here's both of the different warehouse bays that they had set up. And then here's another image that they supplied to us that we had not seen before. So they're really getting more granular here with their software and the modeling of the condominium. And see these big, taller, green piles here. So they've characterized most of the piles down to their depth underneath the building. And from what they were describing is they can turn on and off any column they want. They can turn off the whole building and just leave 2 or 3 columns up and running so they can examine things with a lot more granularity. Okay, so now what they've done here, they're talking about the corrosion studies and the evidence scanning specimens. So they're showing the different types of failure modes that can happen here to cause internal cracking and surface cracking or delamination or spalling. And so they have this column here lying down, and it looks like, so that's for the parking space number 29. So let's go take a look at that and see where that is in the map. So you might remember seeing my map. I made this back in July and have been updating it over the months as different evidence comes in. So space number 29 is right over here. And you can see that column would most likely be either this one or this column. And I believe it was probably this one. And if I'm not mistaken, this one was actually outside of the collapse zone. But I remember making notes at the time here that that was one of the columns that was still standing after the punch shear collapse of the pool deck, which most of it took place right in this area. For example, if we look at this photograph here of the rubble pile, here's column 28 for the space number 28, just to the left of it. So the column we want to see would be over here. But you can see all of these columns in the pool deck area survived. They didn't even crumble because the building was over here. The building's just north of them. They were all standing up, and it looks like the pool deck had done its punch shear. Remember, the pool deck was up here on top of these columns. This is where the connection points are. So it looks like it slid down 5 or 6 feet down into the garage, and what we're looking at here is they're standing on top of the cars. Okay, by the way, one other thing that sort of came out after the Miami Herald released those photos showing how this planter had cracked 2 weeks before the collapse. Look at the spaces where we're at. Remember, this white means you're down on the garage here at this point. Spaces 73, 74, 75, and 76. They were saying that this column right here, number 76, is the one that the property manager said that was the one where they found leaks. And sure enough, 76, when you look on our map over here, see I have that little puddle there? That's where in Fiorella's video we saw water collected at the bottom of the column here of column 76. This right here is that column for space number 76. He's about to enter space number 76. But look at this puddle that's completely surrounding the bottom of the column of all the puddles that we saw in Fiorella's video. But if you look at this picture, I want you to take a look at something on comparing column 76 to the other columns here. Look how nice and white these columns are. See, this one's white, nice and white, nice and white. But look at all the stains on column 76 here from all the water running down. We pointed this out on our last video as well. whenever they had pictures of this particular column, the water just running down it. If we look at the screen capture here, I made off of a drone footage, and you zoom in down here, see this is 28. Wait, if you just zoom back a little bit, the garage ramp goes between these two. Here's 76, here's space 28, and so the pole right here. So I don't think that this column 29 even collapsed at all. So when you look at it here, not sure why it's in pieces. Does it matter? Who knows? So you're probably wondering then, why are some of the columns in pieces if they were intact when the building collapsed? Well, you have to be able to remove them from the site somehow. You're going to have to make a cut somewhere. So if you look here, for example, at this video that I shot back in March when I went down to the site to capture the status of the site, as you look around on the garage floor there, you can see where every single column had been cut out eventually. And where do they do it? They cut it usually 2, 3, 4 feet above the floor, because they don't want to damage the floor. They've already got enough water intrusion problems there. So here in May 22, what they were saying is they have the collapse model contract ready, and they were doing some preliminary subsurface characterization. So that says to me they know what was going on beneath the foundation now as of May 2022. So they're also working on developing this first generation of the collapse model, and they're finalizing the structural testing program as well. So they're going to look at the loads in different regions around the slab, around each column here, and find out what was going on. Where is it weak? So you see here they're showing the 9.5-inch slab, and here it is around the column, and here's all the moments, and where is there going to be something that's going to break. So then the co-chair, Glenn Bell, got up and started to talk about the hypothesis and how they're going to arrive at their failure analysis. And so he was saying here with the hypothesis, it's a constant ongoing activity, and it includes the initiation and the progression of the failure here. So what they want to do here is that they must find a single valid hypothesis, and you have to disprove all the others. So that's how they're going to arrive at their root cause. And he knows that there's going to be multiple potential causes and contributors. So if you remember on my previous video from a couple of weeks ago, I showed you how everybody is remodeling their units over the years, and they've replaced, the small mosaic tiles in the bathrooms with big, thick, fancy stone going all the way up the walls, and big, heavy granite countertops. And it's pretty interesting to say that so far they haven't ruled out anything at this time. Now, I've already ruled out a bunch of things myself. So the way they're going to arrive at their failure hypothesis is they're going to be looking at building strength and building loads, and running these all through their computer simulations and come up with a progressive analysis here as to how it progressed. And then they're also going to be looking at the actual collapse evidence analysis. These two will feed together to arrive at the final root cause. That's their methodology. They're also going to build an official collapse sequence, a timeline. Like this happened at 1:15 a.m. The tourist, like the initial pool collapse happened at 1:15 a.m. The tourist took the video at 1:18. Some of the first phone calls into 911 started coming in at 1:17 a.m. And then the building collapsed at 1:22 a.m. And then the police arrived at like 1:24 a.m. So these are the timeline things that they're going to look at. And they're also going to go back in history and look at all the building permits. They've also been training all of their team members in uncertainty quantification. So the uncertainty quantification is sort of like a science where you look at the numbers and the characterization of numbers and data that you've collected, and you try to reduce uncertainties. Like, what would the outcome be, for example, if you don't know X, Y, or Z? Would that change the outcome? And so it's a type of science that they're training all of the team members on right now to be able to better conclusions on what could have been the root cause of the disaster here, of this condo collapse, without knowing certain inputs. So here's where their bottom line statement is, and this might be confusing for some of you that don't understand like the whole engineering thing and the way they do analysis. They're marrying here the progressive collapse analysis that I showed you above and the non-quantitative collapse evidence analysis. Stuff that they can't put a number on. Oh, there was water leaking over here. We don't know how much weight it added, but it was leaking here and it did something. So you have to be able to combine those two to reduce that uncertainty. Okay, this is the same sort of, they've kind of cleaned up that chart from November that showed us the 6 different projects that they are working on to arrive at the root cause. So this is nothing new. This is 6 months old here. You're going to be looking into the building in the code history. Was the building built the way it was supposed to be according to the codes at the time for concrete? Okay, now we're getting into the material science part, which is pretty cool. And what you're looking at here is the machines that can test the compression strength of the concrete. So what they'll do is they'll take samples and they'll stick it on a machine like this, and it starts squeezing from the top and the bottom into the middle until it just explodes and the concrete goes flying everywhere. That's how they characterize how strong the concrete is. That's the data you and I can't get right now because we don't have any of these concrete columns. And they also did the geotechnical engineering. I believe they're still doing some of it there on site. They're looking at the structural engineering as well. So I guess what they're doing is the social science here is it's being wrapped into Project 2 right here under evidence collection and preservation, because that's where they have Emil Ganapati right there. See, and they're just basically showing here that they're going to take these 6 different projects, blend everything together, and develop and analyze their failure hypothesis. Then what they gave us here was an even much more crystal clear update as to their timeline of the investigation. So here, see all of the different testing they're doing, for example, like right here, the LiDAR data, drone maps, and all that. So they're still going to be sending drones and stuff over the property. I don't know when the judge is going to allow them to develop the property because they can't do anything until NIST is done with all of this testing. So they're doing image and video processing, forensic analysis, so all sorts of different projects going on here. And if you remember that color-coded chart we showed you a few slides back, showing you the different projects, these are those different projects and their timelines. And as you can see, at the very end here, at the bottom of the slide, is their recommendations and report, which it looks like they want to have it somewhere here by the end of 2024, and hopefully it won't go into 2025. So that's their goal, is to have everything done and submitted and collected up together. This here is our first look into the NIST official guesstimate, if you will, on when they think they're going to have the investigation done. So we still have a couple of more years to go on here. Okay, so it looks like they've overlaid the Microsoft project milestones and stuff on here. So somebody's already been planning all the little milestones for each of these projects that they're working on that will all come together for the root cause. So all of this information will flow, okay, into the structural analysis. And you can see here, they're going to continuously update the structure and geotechnical models that they have based on the results of all these different tests and projects. And this could be like a feedback loop, you know, where something changes and then they update the testing and simulations, and then more data comes in and they feed that back in and they update it. So it's going to keep refining itself over time is what it looks like to me. And here's the $22 million, and it's to remain available to them until September 20th, 2023. Okay, so here's their allocation here. So 10 million of that is going to the labor, 8.5 million to contracts. So they're subcontracting out a lot of work to different software simulation companies and outside engineering testing labs and stuff like that. Okay, and then they're also going to incorporate here, as you can see, an invasive testing plan where they're going to extract and test several hundred concrete samples, probably out of all of these columns and slabs, and they're going to check it for the structural and mechanical properties, as you see here on the bottom. And then they're also going to check it for the material and chemical properties. They're also going to look for any type of degradation. For example, if water got in and did it degrade the rebar in the middle and make it rust and make it spall and crack the concrete. Okay, so next that they talked about the 3D visualization of the evidence. Okay, so their goal here is to collect and document everything, identify the original location of every piece of evidence that they have, like where they found it. And so what they're doing here is they're showing you, here's all the tags that they're doing, the evidence tags, the caution tags. And then if you look over here, you see this little round black thing here next to the number 4. That's an RFID tag. So every single one of these columns and chunks of concrete that they've got here has an RFID tag on it. There's a new picture we haven't seen before. This is inside their warehouse. So here it looks like they're scanning an RFID chip on one of the columns. So theoretically, they can walk up to any piece of evidence anywhere in these buildings and just scan it with an app on their phone and pull up every piece of information they'd possibly want on this debris. That's pretty cool. So here's the information that they can enter on each one of these pieces of debris. I mean, just everything you can imagine, the longitudinal reinforcing bar observations, the cross sections, everything. They can also give it other identification clues here, like, oh, there was beige exterior paint. Oh, this one had some waterproofing membrane on it, and give a description. So this will help them narrow down where this piece of evidence came from. And then what they were showing here is they're going to combine these data sets, all of the structural information from the building plans, the measurements that they find that will give them clues as to where it came from, the field data that you see over here, the geospatial info, and triangulation of the photos. And they can also go by the timeline of the floor level recovery when they started pulling everything out of here to empty out the site. So for example, here's an identification they were looking at. So you got these two columns. So you have this column here. This column spans across 2 floors. It's a 2-story column. Right here in the middle of the column where you see it gets thin, that's where the slab or the floor had sheared, did a punching shear there. So they look on, this is one of the pages from the floor plan, and there's only 3 possibilities here. If you look up at the top, see, like, they know it's a 16 by 16 column, so it has to either be a type C, D, or E. And then when you look in C, D, and E, and they knew that, for example, that there's the 8 number 9s and 8 number 10s. Right? So where does that appear on the chart? Well, they found 3 different possibilities here. They now know that this column over here that spans 2 floors possibly came from the lobby to 2nd floor, or it was the 2nd to 3rd floor in one spot, or it was the 2nd floor to the 3rd floor in another spot. See, so it's a lot easier than you think it would be to narrow down where something came from. And they can also use the floor plan to kind of look at all of the possible columns where it could be. So see how the blue locations here are possible columns, and then the red locations, they've looked at them and they go, no, it's definitely not that one. Can't be there. So here they can go by the drone photos or other photos that they found out on the field, or even the LiDAR, to help give them better confidence as to, like, all right, which column was this? Now, one thing interesting here was they're doing their models. I mentioned this earlier for you. See right here? The data grouped in layers that can be turned on and off. So that's interesting. You can move something out of the way so that you can see what's going on behind it simply by turning off different layers. So here they're giving us already a preview of one of the 2D maps that they had. And you can see over here on the left what they can do is they can control what parts of the map are on or off at any given time. It includes subsurface investigation data. So this shows that they've been able to characterize what's been going on down below the ground. So now some of the work they're looking at is they want to start coming up with some failure scenarios, like, what if this column breaks? What would happen? And it'll be able to tell them, will the whole building collapse or not? So they can play what-if games to their heart's content. Okay, so next they talked about the social science and the additional evidence. So this is where that new group comes into play here. And so they're going to be looking at interactions across 40 years here, from back when the building was first built, the design, construction, maintenance, the failure, the response, and the recovery. And then here as part of the social science that we mentioned, they're going to be doing interviews and focus groups and surveys and field notes. And here they're going to be looking through all sorts of stuff here. See, the newspaper articles, the social media posts, audio recordings, body camera stuff. Remember that video we did on when the police arrived? We're going to be looking at everything, the drawings, the building codes, you name it, they're going to be looking at it. And then this term here, see, remotely sensed. This here is a term that means a way of collecting data without touching something. So for example, they took a video of something or a picture or a LiDAR. You're not actually touching the item. So it's important to denote it, whether it's remotely sensed or not. So having the social science, I think, helps with public opinion. I think that's one of the biggest benefits right there. And then, of course, the same thing here with the building safety perception. There's a lot of people around the country that are wondering, hey, is my building next? How do I know if my building's safe? I live in a high rise, So those are the questions I get all of the time. And here, see this? This is what I brought up in my last video. Changes made to the building over time. That includes all of that extra pavers and sand that they added to the pool deck, the palm trees that they added to the pool deck. They added all of those they added the extra planters to the pool deck. And then they have to ensure accuracy of the information that they're collecting here too. So they use techniques that will increase the correct information retrieval, like cognitive interviewing, stuff like that. They'll use maps, plans, and photos. All of that all kind of tie into making sure that everything somebody tells you is how it lines up. Like, there's a lot of people that think that the fire alarm went off in the building before it collapsed, but it did not. People thought they heard the fire alarm in the background when the police arrived on the body cam videos, but it was not. It was from the building next door. It was from the hotel, because they had evacuated as well as a precaution. So their first priority here, as you can see, for the social science, is getting the information, and the evidence here is getting the information from the Champlain Towers South residents, the relatives, the staff, condo officials, contractors, inspectors, and consultants, and anyone who may have seen the collapse, and anybody who may have been familiar with the construction and the inspection practices all the way back to 81 when the building was built. Now, here's one that I thought was interesting. I kind of like this one. So they are adding also, but it's priority number 2, Champlain Towers North and Champlain Towers East residents. So they're going to be talking to them. Hey, what have you seen in your building? We know that especially Champlain Towers North, they call it the sister building. It's not exactly the same floor plan, but their floor plans were included together in the same packet. So much of the garage is the same design in both buildings. And so they want to see what were they noticing wrong in Champlain Towers North. Now, here's something interesting too, is they also want to provide unique perspectives from outside and inside the building. And look at this. We have our famous tourist video here. Here's a screenshot. And then our friend Fiorello Terenzi, who took that now famous video tour of the garage a year before the collapse. But here's something interesting. Take a look at this. They have greatly enhanced, I believe, both of these pictures, but much more so. Look at this. They took that cell phone video that Adriana shot and really went to town with it. Now, I've spent hours doing Photoshop on it, on the screenshot. I've even had other Photoshop experts send me much improved versions, but this one is the best one I've seen yet. It's so super clear. So right here, as you look down the garage ramp, of course, you can see the 27 on the column there. And this is funny. So they made the C come out nice and clear. That's for Champlain Towers. It's on the gate. So many people have commented. They tried to say that these were the laundry machines that fell down from the laundry room above, and everybody was previously pointing to the C because it wasn't this clear. And they thought this was like the window on the front of the washing machine. But anyway, when I look here, here's where they really bring things into clarity for me. You see all of this kind of bluish green stuff right here? And I think that's the planter as well. I think this is all from Sarah Neer's condo unit number 111 out on that famous 11 stack out on the pool deck. Let's take a look at it. As I look at one of the MLS photos that we've been showing you, because we used to show this picture last year, because see, this is where they did the digging. M11.1 is right here, and they dug up the pool deck right there and they left it dangerously exposed for months before people started complaining. Here's 111. That's Sarah Neer's unit right here. That's her patio deck. And look at the color of this furniture there. See that kind of bluish green? Doesn't that look like that same bluish green right here? That's what I think. And this white right here, that could be her table, that round white table out on her deck. So I'm pretty convinced that when Adrian shot down the ramp into the garage, the pool deck had already collapsed, and that's Sarah Neer's patio that's collapsed right there in the background. And I still maintain that we don't see that third column, which should be somewhere around over here. It should be somewhere right around here, based on the spacing from the first to the second one, and then it would probably be somewhere in this area, I would think. So this is probably the best view we've seen to date. And then here's another MLS shot that I got looking down on the pool deck. And here's Sarah's patio furniture sitting right here with her round white table. So there's all of those bluish greenish chairs there. Column M11.1 is right here beneath this planter, and there's supposed to be a beam here, and there's supposed to be a beam underneath here as well. So that's why all along one of my hypothesis was that if this M11.1 collapsed right here and it took that beam with it, it would then pull on the column which is right here on the south wall of the building, which is column M9.1, M10. See, here's 11.1 right here. So if it pulls on the beam that was right here, it will take M9.1 with it. So they're also going to be collecting data from the drones and stuff like that. So that's what these are here. These are photos we haven't seen before either. I don't think we've seen any of these vantage points. And here's an interesting drone view looking straight down the shear wall. This is the part of the building that survived. So because of this large shear wall here being nice and solid, and all of those beams they had on the second floor. That's likely what saved this part of the building from collapsing. So then they have other drone videos of a lot of the columns that punched through the deck right here. And now here's another great one. Let me show you this here, what they did. So they took that video. Actually, you know what? Remember, we've all seen that now famous video that went around the world of the building actually collapsing, but we didn't see it with this amount of clarity. What they did, of course, NIST has access directly to the file. What you and I were looking at for all of these months was somebody's cell phone video off of a screen showing the collapse. Here you can see how crystal clear, relatively speaking, compared to the video that we all have. And then they sent a team of people over to the actual camera at 87 Park at the condo next door, and they did calibrations on it. So they did these different cards to test and calibrate the camera. I'm sure they likely did white balance cards and grayscale palette cards as well. So it says here, commercial and home security camera videos. They didn't mention Champlain Towers South video cameras. What about all of the cameras around there? And I keep pounding the tables about this. Where are the videos? They gotta have it. Somebody's gotta have it. They're like sidestepping this one. They're dancing around this one because they haven't said we don't have the video, and they haven't said that we do have the video. So they're not telling us anything. They're concentrating on showing us this, but they're not saying anything. They're being mum on it, and I don't like that. These videos will help understand the timing sequence and the motions and understand the initial response as well. So it says what they've accomplished so far is they've collected high-resolution version of some videos. Okay, well, the only high-resolution version I know of would have been this. So if they've collected some videos, does that mean there's others that we don't know about? Is this the Champlain Towers ones that we have been asking about? We simply don't know. So here's where they're saying they collected the calibrated data from the 87 Park camera, enhance and analyze and obtain the remaining videos. And then, of course, these are two, I think we have not seen these before. These are the results of some of their LiDAR testing. These pictures they released back in July. These are old. These two over here on the right, I think, are new. That's what the output of the LiDAR looks like. And they've processed and aligned about 50% of the scans so far. And they're going way crazy on this. They're also using some of the INSAR data from the satellites. So it'll give us any kind of movement insights, like what was going on the ground over time. And here's more of the 3D scans. Remember I showed you these two pictures before of the bird's eye view of the two storage bays showing all of the columns in there, and of course pictures and cross sections of the different columns. For example, here's some of the rebar you see on there. And they're going to be looking at this rebar, like, are these two rebar rods too close together? If they are, you can't get the concrete to pour correctly between them, because look how big the aggregate is in the concrete. Okay, so next they talked about non-destructive testing of the evidence. This is where they go over to the site and they do things where they're not drilling into the concrete or anything like that. So here they are doing the non-invasive testing. They actually started doing this back in August. See here, so they do not alter or damage or destroy the site or anything here. So with the non-destructive testing, it's collect the data, do your analysis, provide the insight. Very simple. And so, for example, here, they can also do it on the column. So here's a column that spanned across 2 floors, and here's where it ripped with the punching shear. And this is typically what you're left with, the textbook kind of mushroom shape cutout there. And so they can start analyzing those to see what was going on. And I think that's sort of what he was doing here, too. This is one of the older photos that they gave us last July. Yeah, so they use the GPR, ground penetrating radar. And they do this a lot, too. They use the ground penetrating radar whenever they're going to take a core sample out of concrete, because you want to use that radar to make sure you're not going to drill through a rebar. You only want to be sampling the concrete at that point. So that comes later in the destructive testing. And see over here on this lower left, you can see they were doing a manual measurement of the slab thickness. So they have to cut a core out of it, and then they measure it. Just because it's, let's say it was 12 inches in one area, it doesn't mean it's going to be 12 inches in another spot. So they have to check in several locations. So here they're showing how they do the rebound hammer testing as a non-destructive element. And then they do contact pulse velocity as well. Okay, so this test here, the contact pulse velocity, they use it to help to measure the speed of sound going through like the concrete. They'll put detectors on there and send a pulse and measure the speed, the time that it took to get to the receiver end on the other side. And that helps them kind of, that can indicate the presence of damage in the material too. It'll give them a good idea as to the quality of material, because, they have references. They know what a good column, a 16 by 16 inch column, you run a certain sound through it, through your test, they know what it should come out on the other end. And if it doesn't come out like that, then something is wrong. Okay, then they were showing how they were doing impact echo. So they put a machine down on the ground, and there's the guy using it right there. And they send sound waves down below, and if it hits a flaw, when it bounces back, they'll know it. They'll get the reflection back from the flaw. They also use spectral analysis of surface waves, and there's their testing equipment. You see the guy using it here on the right-hand side. And this, I'm willing to bet this is done through a contract, because all of these images here are from Olson Engineering. I'm willing to bet they're the ones that are going to be doing all of that testing. I imagine they're the ones going to be doing all of that testing. Here's the ground penetrating radar. So that's how you identify if any conduits or rebar or anything that you need to avoid when you're going to drill a core sample. So if you look at the number of tests to date, they've taken 1,800 data points on 39 columns and 19 slab pieces of evidence. And then on-site, they did 45 locations to evaluate the below-grade foundation. All of the non-destructive testing they've done so far affects all of these other guys, the material science, geotechnical, the structural. Yeah, so the next thing they want to do is evaluate the as-built conditions of the building. They want to look at the geometry, the features, any kind of damage or voids. That's what they're looking for. They want to see, does any of the material they've collected so far show any evidence of voids or things like that. And remember here what I mentioned earlier, assess and quantify uncertainties as the propagation of source of uncertainty to the hypothesis analysis. Of all of the items they don't know, how is that going to affect the outcome? So next, they covered the invasive testing of the evidence. So this is where you start getting old school on it. You start drilling. So here they showed us some new pictures that we hadn't seen before also. Now here's, for example, of a core test. Now these are not really all that new. You've seen us show you that they had done some core test sampling on the site before it collapsed. So we've showed you that in some of our videos in the past. In fact, earlier in this video, I showed you that cutout that they made on the pool deck right outside Sarah Nair's condo unit. That's where they did one of those core tests. They'll also start looking at some of the rebar rods here. They're going to start to extract them and cut them open and look at them, send them off to metallurgy experts to see was there something wrong with the manufacturing of them. Here's the laboratory testing. Now here you're looking at the compressive testing of the core sample. So what they'll do is, as you can see in this picture above, they'll cut out the core sample, put it in the machine, and it will come down and squeeze it until the concrete explodes, just like I showed you earlier. And then this one here is the tensile test on the rebar. So they put it on this machine, and the upper section and the lower section start to pull apart until this whole thing just breaks. So that's what they want to do. They want to quantify at what point do they hit failure. And they do have a prioritized plan. So I think this means here that they're only going to take cores when they need something if it's on a specific location. And there's all sorts of standards and guidelines and all that for doing failure analysis and investigation. So they're going to be using those standards. It's not just a haphazard. You don't just drill in, grab a core, and start doing stuff. There's certain testing procedures that you have to follow when you do this. And here's what I mentioned earlier about the ground penetrating radar and stuff like that here. So they want to refine the sample locations that they got from the non-destructive test, so they know where to drill so they can avoid rebar or concrete, stuff like that. So they can avoid the rebar in the concrete cores. So these pictures here show how they accomplish it. They come in with these big old hole saws, and of course they have to do it while it's wet. They come in and they do this wet drilling, and they pull out the core sample, and there it is. There's all the aggregate that's in the concrete, and they're going to investigate and look at all that and say, hey, is the aggregate properly sized? Is there enough aggregate in this concrete? They're going to inspect all of the samples here and to verify the viability, and they're going to look for internal cracks or voids in these cores. Now here I see the guy handling it with his hand. Now I don't think this is necessarily from Champlain Towers. These pictures are from Hover who is the company probably going to be doing the testing. So these are probably just regular samples of concrete they were working with. So don't panic when you see these pictures. So here's all of those physical tests I was telling you about. So here's 4 different tests here. So the first one up here is your compression strength. So remember I told you the machine pushes in on the middle, and then you have the splitting tensile strength where it pushes in on the middle of something round like the core and waits for it to crack like that, and it'll split into half. And then, of course, you have the rebar strength and ductility. And then you got modulus of elasticity. And what that is they're looking to see if they compress down on something, bounce back into its original shape. They're going to be doing all sorts of chemical tests on the aggregates, the paste, the mortar, everything. They're going to be looking at the corrosion, and they're going to see how, like, for example, this red circle here, here's the rebar. They're going to be looking at how does that rebar get rusty and expand its diameter and then cause the concrete to crack. They're going to be hitting this concrete up with all sorts of salt and water, pure oxygen, carbon dioxide, and they're going to be doing corrosion testing on the rebar rods. And they want to know the potential of this uncoated steel. So remember, when this building was built, they didn't use anything like epoxy dipped rebar. A lot of buildings use today. They just threw the rebar in there and forgot about it. So, of course, all of the core samples they take and everything will feed back into the analysis and the modeling, because they'll take core samples from all over the property here and feed the good and the bad and the ugly into these collapse simulations here, and they'll be able to much more accurately come up with a collapse scenario for us. Even though we've seen other good jobs by guys like Mike Bell out there, you've probably seen some of his collapse videos. And remember, we're all just guessing on the outside, but these guys are taking real data from the real concrete and everything and making real modeling decisions from that. And by the way, they're still working on moving some of the evidence around and all of that and finalizing the specs for the invasive testing equipment. So here, this is a couple of good shots that show you what's going on inside that warehouse where they've got the stuff stored. And they left a little measurement here, 6 feet legend. There's I think that's 2 NIST employees right there. So it shows you how big they are compared to the whole massive pile in there. And here's another view looking down inside the warehouse. Okay, in this NIST update on the condo collapse investigation, they talked about this other project they're doing here, the structural testing. So they're going to take the structural testing that they do, feed that into their computer simulations, and also deal with the building evidence. And hopefully by the time they're done, it'll give them a much more accurate simulation model. And of course, they'll look at the historical record. And hey, look at this, folks. They must have seen my video, because look at this. They're talking about the real estate listings and the showings and the pictures that Fiorella sent me that shows some of the remodeling that was done in the bathrooms, right? And so I had mentioned this on our last video, and a lot of people were skeptical of me that this wasn't a stressor. Or I had a number of people accuse me of being a sensationalist, that I'm just trying to do clickbait, and when in reality, these are not unfounded fears. And I'm going to do a second video that talks about my analysis of the weight difference, of how much weight is it different here than what it was in 1977 when they built. All of you guys out there that are naysayers, you've never had to carry a 50-pound bag of concrete. You've never had to carry up all of the tile backer boards. You've never had to carry cases of 12 by 24-inch tile that's 3/8 or a half-inch thick travertine. You haven't had to deal with all that nonsense. So they're going to look at detailed structured measurements. So here's some good shots inside the warehouse here. What they're doing is they're taking very good, accurate measurements of like all the rebar rods, and they're mapping it out, and they're seeing, hey, is everything where it belongs? Is the right amount of rebars in there? Are they the right distance apart? And here's more of that mechanical testing that I was telling you about. Here's that compression strength testing here, and then here's that splitting strength, where they bear down the weight on this core sample here until it splits right down the middle. Standards they live by. So when some people, there's a lot of conspiracy theory people out there. There's a lot of people bad-mouthing and trashing NIST. Oh, these guys don't know what they're doing. It's usually the people that don't understand the science behind something are the ones that don't know what they're talking about. And they're talking about it from a standpoint of ignorance. Because we did testing like this many years when I was at Motorola as well. We would test, we would drop test and do compression strength testing testing like this on our displays on our radios. They're going to look at the concrete mix. They're going to check out the binders and everything. So they have, engineers and scientists that are like the best of the best in their fields, looking at this thing from a million different angles. Here's more of that slab column testing we were talking about. So here when you have, this is your column. If you look at these three pictures in the middle, you have the column, and then you have the slab here, the floor slab. And then you have the rebars that curve up and go into there, and that's all poured as one. So they want to examine that, and they want to see if there's any corrosion that shows up in there in the middle. And they're looking at the case where the columns are intersecting with the beam A's as well. Yeah, they're going to be looking at the moment forces on these as well. They're doing accelerated corrosion testing. We used to do this when I was at Motorola too. We used to call it ALT, Advanced Life Testing. We would take radios and run them through temperature and humidity cycles of like minus 40 degrees Celsius up to 100 degrees Celsius and back and forth for like a week, trying to accelerate the life of it and, inject dust and stuff like that in there. So here they're making a salt pond on top of their concrete slab to see what it does to it, to characterize how will it fail. And this is where everybody's been talking a lot about it ever since day one of the collapse. And they're referring to this area right here where I pointed to at the very beginning as well, the 5 columns that fell. They're on the exterior wall of the building, and they sit on top of this beam. This is the beam here. And so what you have here is you have the pool is this way, the lobby's this way. So the pool sat on this 9.5-inch deck right here, and then all of a sudden, you get to this floor concrete, you get this step up here, and everybody was analyzing these step ups and what could have gone wrong. Could there have been shearing forces? What's going on here? So they're doing all sorts of testing on this as well. The slab beam column connection. That's such an important thing. This is why we had punching shear. It may not have happened in this spot, right at the edge of the building, but if you look out over in the pool deck, it certainly happened out there. So that's why they want to know what happened with all of these slab beam connections. And then they did basement column testing as well, right? So they come down here to the basement slab right here, which is the garage floor, and they want to look at some of these dowels here. They want to know, where was the splicing and the position of them? Were they the correct length of overlap? They're going to look at a whole bunch of different things here. And so they're taking test specimens and doing cross sections and taking measurements over here, like you see on the right, as to where all of these rebars were in the column. And are they spaced correctly? The next project they talked about was the computational modeling and analysis. So they start looking here at dead, live, and wind loads. So this is where I was talking before, like, for example, the dead load would be all of that stuff they added in the bathrooms when they did the remodeling, and all of those illegal tiles that many, many units inside Champlain Towers South had out on their patios. And here for the first time, man, this looks like one of the first close-ups we've seen yet of one of the pool pavers, the big square one here. They're going to look at significant wind events. Like, for example, we had a small hurricane that came through in 2017. We had Hurricane Wilma in 2005. We had Hurricane Andrew in 1992. And we had a few others in between. So they're going to look at the historical records of loads on the pool deck. See, that was another one. Remember I kept telling you guys, see, here's that picture from Google Maps probably, from Google Street View, before 2017 when they removed these palm trees. But these palm trees were added in 1996 along with these new planters that are holding these palm trees. So that added a significant amount of weight onto the pool deck along with all of these pool tiles here. Adjacent construction. That's their way of saying, hey, we're going to be looking into 87 Park. That's the condo next door that was part of that big lawsuit that just got settled a couple of weeks ago for over $1.1 billion. So they want to, if you look over here on the structural design, they want to figure out the degree to which the building, the way it was designed, did it satisfy the building codes and other standards and practice at the time. There's certain things that are not allowed today that would have been done and perfectly fine back then. And that's what they're going to do here. They're going to evaluate all of that against the current codes and the current standards of practice in the industry. Here's another interesting model. I like this one here because it shows us the bottom of the shear wall. So here's the big shear wall, and then this is the part of the building that collapsed up here on the upper part here. And one of the contributing factors of why it collapsed may have been the fact that look at the shear wall over here, highly inadequate for this size of the building. But yet this section of this part of the building here, this shear wall was huge. And then they're building a grid here. This is a drawing showing all of the slab reinforcement, all of the rebars around each of the columns. We know what it says in the drawing on the floor plan, but now they're going to make sure that each one of these connections actually had those rebars there, and were they the correct ones there too. They'll feed all of that back into the modeling software, and it will determine whether or not this building was structurally safe. So basically here they're talking about, they're just taking all of the information that they've collected and everything, and it's getting fed back into the simulation software. Wow, that was a lot of tech stuff in there, and I know it was a little bit longer than normal, and thanks for sticking it out this far. But yeah, you asked for it. You asked me, what is the status of NIST? What are they doing? What's happening with the investigation? And yeah, now they're getting into the nitty-gritty technical stuff. So yeah, there was a lot of stuff to disseminate here to you. So I hope this helps you understand better as to what's going on right now and where they stand and what that timeline looks like. So thank you so much for joining us tonight, and we'll see you on the next one.